Welcome everyone to GitOps in action. My name is Jimmy. I work as a cloud architect at Knowit, and I also focus on ways of working and DevOps and CI/CD pipelines. When we start, I like to start to compare DevOps versus GitOps. What is the difference? Can't we run GitOps without having DevOps and vice versa? As I see it, DevOps is about people. It's the movement when we started to bring the development teams and the operations team together as one team to ease the way we deploy code, the ease we run code, and the way we operate code in the cloud. GitOps is more of the technology aspect of it. It's the way we use technology to help developers do operation changes in production. It's how we set up the CI/CD pipelines and how we work with Git to enable this. So for me, DevOps is about people, and GitOps is more about technology. So starting at the basics of GitOps, we use Git as the single source of truth. This is where we put everything. If it's not in Git, it's not belong in our production environments. It's a single source of truth. Everything must be in Git. With that, we get a built-in audit trail. We know what happened to our production environment, and we know when it happened and who made the change. Pull requests is the heart and soul of GitOps. Everything goes and flows through pull requests in Git. We get the good things like code reviews and team reviewing our changes and improving our changes. We need to have infrastructure as code. We need to be able to spin up new environments automatically. We need to be able to deploy changes into production from Git in an automatic way. So we need to have all of our infrastructure model as code. And we need to have a good automation pipeline. If we can't deploy all our changes from Git in an automatic way, we will not be able to handle this in a GitOps way of working. So as I said, everything is code. And when I say that everything is code, I mean really everything is code. You should model your infrastructure as code using whatever templates you like. CloudFormation, Terraform, Troposphere, whatever it's you like to use. You put everything in Git, in your entire infrastructure. You put your configurations in Git as well. It could be configurations for your different environments, your development environment, your QA environment, or your production environment. You will have to have different configurations. You put those configurations in Git together with the code. And you put documentation in Git. Because it's a natural way to place your documentation together with your code to be easy to find for all developers and everyone working with the code. So put everything in Git, put everything in code. Except one thing, secrets. Don't put secrets in code. I have seen horror stories, I have heard horror stories where people check in database passwords in clear text in Git. No, don't do that. And don't go home now and say, hey, I listened to this guy at Øredev said we should put everything in Git, so let's start checking in our passwords. So don't do that, and don't blame me if you do it. I said don't put your secrets in Git, of course. What you use is secure vault, like HashiCorp Vault, Amazon Parameter Store, or whatever you like to use. And in Git, you just put your references to that secret, so you know what secret to pull. And of course, you put that in configuration files, so you could have different secrets for development, for production, and for QA. There are experiments being done where people have checked in their AWS secret tokens in public repositories in GitHub, and the mean time before those secrets start being used is less than 60 seconds. So, careful. So, how do we start with GitOps? Well, everything starts with Git, of course. It's in the name, GitOps. We start with Git. You put everything in Git. Sounds easy, right? Shouldn't be that hard to put everything in Git. Well, it tends to be. You need to put even your POCs in Git. There is a company called Datree that does DevOps pipelines, helping you manage your DevOps processes. And their CEO, Shimon, I have talked to him and met him a couple of times, and he told me a story once that they were developing a new feature. And to be clear, Datree is really into GitOps. It's their way of working. They are one of the pioneers in this area. And they developed a POC, and they wanted to test it out in production. So they deployed it into production, starting testing it out, routed some traffic to it, discovered that, hey, this works really, really well. This is something we want to run. So they enabled it for everyone, and it worked perfectly. A couple of weeks later, they realized that, wait a minute, this feature that we just enabled in production that is now running and being used by all our customers is not in Git. Since they developed it as a POC, they deployed it as a POC, and they tested it as a POC, they didn't really think about putting it in Git directly. So they had to go back and redo the work, put it in Git, and then try to redeploy everything again to have it up and running. So when I say start with Git, put everything in Git, it sounds easier than it actually could be. But that is where we start. We start with Git, of course. Next thing we need to have, as I mentioned before, is our infrastructure as code. We need to have all our infrastructure model as code. We need to model our service, we need to model our Kubernetes clusters, we need to model our serverless deployments. We need to model everything so we can deploy it over and over again in the exact same time without manual intervention. Because if I give you a template with manual instructions and I hand that template to 150 people, I will get 150 different environments. Because you do steps in the incorrect order, you miss steps, or you misread something. So as soon as you have manual tasks in your deployment, there will be differences. So everything modeled in infrastructure as code and put it in. And you should do it even if it's hard. When I was working at Sony for many, many years ago, we were developing this rather big serverless application. And we had our users logging in. We used an Amazon user pool. And then one day we wanted to hook on a Lambda function to the user pool so we could have some post-logging code being run. So we can process some information about the users logging in. So we wanted to hook that Lambda function up to the user pool. Sounds easy enough. We used CloudFormation. We had already modeled everything. Then we realized that CloudFormation, at the moment we did this, didn't have support for us to add a Lambda function to the user pool. Okay, we went back, figured out, okay, let's use a CLI instead. You can use a CLI, we scripted in Bash. Okay, no problem. Well, it was a problem. Since the configuration for a user pool is immutable, we actually had to download the entire configuration, do the modifications, add the Lambda function, and then redeploy everything again. So we had to download the JSON, parse the JSON, modify the JSON, and upload it again, all in Bash. Funny days. So at one point we were actually thinking, okay, we skip this. We rewrite the manual instruction. But at the end we actually did put in this extra 1-2 weeks of work to have it as infrastructure as code, and it helped us because now we could deploy an environment over and over again. So do it even if it's hard. And automation requires that you have everything as infrastructure as code. Otherwise, you will not be able to automate the setup of new environments. We also need to invest in our automation pipelines. We need to have good automation to be able to deploy this. We don't want to have any manual deployments of applications. We don't want to SSH into servers to update operating systems or update application version. We really want to have this in an automatic way. And what is really important is that our automation is flawless. It must work over and over again, and it must work every time we trigger it. At one of my previous employers, we had invested a lot in infrastructure as code. It's a huge company. They had also developed their own scripting language for their infrastructure and their deployments. It was a fantastic tool. They had put in so many man hours in that. We had one problem in my team, and that was that the automation didn't spin up an environment every time we triggered it. I would say if we triggered the automation to spin up a new environment 10 times, we would have 8 failures. It worked really, really bad. The problem it caused would be that we need to go in manually to get this now half working environment running, and there were just a few people that knew how to do that, and they became the bottleneck of everything, because every time anyone wanted a new environment, those 3-4 people needed to be involved to set up the environment. So spinning up temporary environments, bringing them down was not an option. And that caused people to start treating their environments as pets and not as cattle. So when you had an environment, you nursed it, you petted it, you took care of it, even if you didn't need it anymore. And that, of course, in the end, cost money. So automation must work flawless, so you don't depend on some people know how to do this. You must be able to spin up environments over and over and over again. As I said, pull requests are the heart and soul of GitOps. It's often known as GitOps is operations through pull requests. So why is it that important? Well, since we want our developers to be able to do operation changes, we want them to do it in a familiar way. And in a familiar way from the developer is to open a pull request. And as long as you as a developer can open a pull request, you can do operation changes in production. And most developers know how to open a pull request, meaning that developers can do operation changes in production. And that is really important. You should always go through pull requests, even if it's a super critical change, something is broken in production, go through a pull request to have your teammates looking at it. Because when you have this critical change, you will have like 10 PMs jumping up and down behind you and screaming that this is really important, please get it in, please get it in. And you do easy mistakes. So if by setting it up as a pull request and enforcing that someone else looks at this pull request, you will catch these easy mistakes. And to be able not to actually do push directly to master branch, set up guardrails, make it impossible to do that. Lock down the master branch, so you actually must go through a pull request. Because if the technology stops you, the PMs can jump up and down how much they want. You can still say, I can't do this with the technology stopping me. So pull request is the pulse. That is what we use to do operation changes in a GitOps way of working. What about drift? As I said, Git is a single source of truth. Git is the map. The picture you have in Git is what you have in production. But what if we start to drift? It will happen, definitely. It could be the deployment failing. It could be that you actually have someone going in doing a manual change by mistake or on purpose. So what we need to do is be able to detect. So we need to start by detecting drift, and most infrastructures code tools have a drift detection. CloudFormation has it, Terraform has it, and all the major tools has a drift detection. So now you can start to detect, okay, the picture I have in Git is now drifting from what I have in my QA environment or in my production environment. So what do? Okay, we need to remediate this. And how should you remediate? I would say it depends on the situation. It could be, is it a failed deployment? Well, maybe just redeploy and everything is back to normal. Was it a manual change being done, like in the Datri case? What should we do then? Maybe you need to put it in Git and redeploy everything to have it back again. So how you remediate the situation like that depends on the situation. A good way to minimize drift is, of course, to keep people away from production. Don't let people in. Just let automation in. Set up guardrails. Make sure that the people that had access to production only has a read-only access. Since you're doing everything through automation, through Git, why do the people need write access in production? They don't. They need read access. That's all. So that's one way to set up a guardrail. Keep them away. CI/CD then, when we're talking about GitOps, there are two patterns normally used. We have a push-based pattern, which is the most familiar one, and we have a pull-based one. That is one of the more specific for GitOps way of working. In a push-based CI/CD pipeline, it looks basically like this. You have a change in Git that triggers your build pipeline, that builds an artifact, puts that in an artifact store, and then you have your deploy pipeline being triggered. It picks up the change and it pushes the change to production, QA, and dev environments. The normal flow. This is what most people are familiar with. This is how most CI/CD pipelines are set up today. In a pull-based CI/CD, it looks more like this. You have this change in Git, still triggers a build pipeline that builds an artifact. Then the pipeline stops. In each environment, you have an operator. That operator pulls the artifact store for new artifacts, detects that there is a new version of the application or the infrastructure being uploaded to the artifact store, pulls that down into the environment and deploys it out to whatever environment the operator is running in, QA, prod. What this gives is that you get a really strong isolation. Your CI/CD pipeline no longer need access to your production environment. It only need access to your artifact store, where you put your Docker images or your zip file of your serverless application. Then the operator needs the access to the production environment or the QA environment. But the operator is still already running inside of the environment, so it already have all this access it need. And an operator can only deploy to the environment it's running in, meaning that the QA operator cannot deploy to production. A production operator cannot deploy to QA. It can only deploy to the environment it's actually running in. So it gives you really strong isolation. There is one flaw with that, and that is if you want to use temporary environments, how do you get those up? Because you don't have an operator running in a temporary environment, because then it's not a temporary environment anymore. So what I like to use is something like this. I like to use a combination of them both. I like to have a change in Git, trigger my build pipeline, building my Docker image, putting that in my artifact store. That will trigger my deploy pipeline, and the deploy pipeline sets up a temporary environment and deploys that new image into that environment. Now we can use this temporary environment for testing, automatic testing, manual testing, whatever testing you have, you do that in this temporary environment. And when you feel comfortable with the change, you know, okay, everything is working, you can merge the change in Git if you build it off pull requests, or you can just tag the artifact in the artifact store saying that this is now ready for production, it's ready for QA. The temporary environment goes down. The operator in QA environment, for example, detects that there's now a new image being tagged as released to QA. It pulls it down and it deploys it to QA. I like this pattern. I use it myself at work today. Okay, the session is called GitOps in action. So we should have in action part, I think. We're going to have a short demonstration, and where we are going to do something like this. What we're going to do is we're going to open a pull request. We have a change in our application that will open a pull request. It will trigger our pipeline, build pipeline, and our deploy pipeline, and we create a temporary environment. And to be able to do this, I built a small bot called JBot that will do all of this. When we are happy with the change, we know that everything is working, we will merge the pull request. That will trigger our build pipeline, and that will create a new artifact. Then we have our operator in production detecting this artifact and deploying it into production. So if GitOps flow, we're going to do an operational change. How have I built this? Built it like this. I built this on top of AWS components. Of course, it's nothing you have to do. You can use whatever CI/CD tools you like, Azure DevOps, or whatever it's your favorite tool, Jenkins maybe. But this is how it's going to be. We have our code in code commit. We do a pull request that is triggering my JBot that is built in Lambda. That will trigger a build pipeline that will create a new temporary environment in an API gateway. We also will have JBot commenting back on the pull request with the link to the temporary environment. And when we are happy with everything, we will do merge, and JBot will take care of the rest, and we deploy everything. So let's do this. So what are we going to do? Well, we are a new cool startup. We rent out unicorns. That is our thing. So we are a unicorn rental business. Today we have one unicorn that is named Luna, and her special feature is wings. But it's not that good to be a unicorn rental business if you only have one unicorn to rent out. So we have actually been able to catch one more unicorn. So that is what we're going to add today. We're going to add one more unicorn to this setup. So if we move to here, we can go to our production environment just to see that one. So here's our production environment. Go to our V1 stages. We just open that one up. And you see that we get one unicorn back. We get Luna back with our feature wings. Okay, so now we start to add this. The database in this exercise is a simple JSON file that is bundled with our application. Since we don't have that many unicorns, we didn't really care to set up a true database. So what we need to do, we need to create a branch. So we create a new branch for this work. We push that. To our central repository that is code commit. Okay, so let's do this copy paste exercise. We have our new unicorn. The name is Gaia, and the unicorn's feature is speed. So that we have, now we have 2 unicorns. So we want to push this. So we can open it. Oh, sorry, of course. So I just do the commit. If we check the JSON file again, just to make sure that everyone saw it, we have added our unicorn Gaia here with a new special feature of speed. So if we move over to our repository here. Oh, sorry, I need to push it, of course. A bit hard to open it otherwise. So, being in my repository that is code commit, let's go to my demo. We create a pull request for this. And we detect that we have a new change here. Of course, we have added Gaia as our new unicorn. So we just add a message in our pull request. And we create that one. So now we have opened the pull request. JBot will now detect this pull request being opened and will start creating a temporary environment. So what we can do is move over here to my code build. We can check in my build pipeline, and that should be perfect. There is a build now running. So JBot has now detected that we opened a pull request, and it has now triggered our push-based pipeline to build an artifact and push that artifact into a temporary environment. This will take about 2 minutes. What we can do is we can go and look in my, as I said, this is all done by infrastructure as code. We need that. I use CloudFormation as my weapon of choice. So we can see here that now I have a new temporary environment spinning up that is called number 27 here. We have already created one part of the infrastructure, and we are now creating the second part, which is the service part. So what have we done now? Okay. So going back to the presentation, what have we done? We have So what we've done now is this part here. We opened a pull request that was detected by JBot, and that has triggered our code pipeline, our code build line, and we will have a new environment. As I said, we will have comments on our pull requests. So if we go back to code commit here, check out the activity, we can see that JBot has now added a comment saying that I have started a new build with this for this artifact. And of course, we are being a cool startup, right? We use Slack. Of course, we use Slack. So JBot will also add comments in Slack that when a new environment is being created. We can see here that we have a build with build ID has started, and we now actually also have the link here to the temporary environment, and we should have that in here as well as soon as it's done. Yes, and there is also a link. So what we could do now, we copy paste this. Copy paste it. We go to the unicorns listing. We can now see that we have 2 unicorns in our new temporary environment. So what we've done now, we have from a pull request, we did an operational change. We committed that as a pull request. We had our bot create the temporary environment, and we can now see that the temporary environment is actually working. We are happy with this change. We now want to merge this into production and have code deployed into our production API. So if we move back, we can see in our APIs here that we now have a temporary environment that is called Unicorn Rental API 27. The name is based on the pull request ID, so you can understand I run this demo a couple of times to make sure it works. So we can, if we check out the production environment just to see that I'm not cheating, we will get 1 unicorn back here. Yeah, we still have only one. Still only have 1 unicorn in production. Okay, we are happy with the change. We have tested it out. We are now ready to merge this. So we go back here to our pull requests like this, and we just do merge. And we just commit it. This will now create trigger cold build again, and we will actually end up with an artifact in my artifact store that I'm using S3. You can see it's empty at the moment. Going back to my build projects, we will see that we have a prod build being done, and it's running right now. It takes a couple of more seconds, and when this one is done, you will see that we will have an artifact, and the build pipeline will stop. It's no longer needed. Operator will take over. So now we have a new, we should have an artifact packaged in S3. Yeah, there it is. So what we done now, we merged the pull request that triggered our build pipeline that created a zip file actually with all our code changes from that pull request. It created an artifact and it uploaded it to our artifact store. In this case, I'm using S3 and zip files. You could be using any Docker images or Docker repositories or whatever you are how you are building your application. Doesn't really matter. What will happen now is that my operator JBot will detect this new artifact and it will deploy it out to production. That is rather quick actually, but we can go into our build projects that is have a deploy here for production, and you can see it run just now. So we actually have been doing this perfectly. So okay, we have deployed it to production, then we should be able to see it in production, right? I just refresh the API, go to the get function again, and we now have 2 unicorns in production. What we would like to do now, when you have merged the pull request, is of course bring down the temporary environment. You don't need it anymore. I have not taught JBot that thing yet. He will not bring down any temporary environments at the moment. But that is the next thing you want to do. You don't want to keep your temporary environments running, so you bring it down when you do the merge of the change and it's being deployed. So going back to the presentation then. So as I said, this is what we've been doing in the short demo. We opened the pull request that triggered our JBot, that triggered our build pipelines and pushed it to a temporary environment. That pattern is actually being used today at work. I have set it up so when we do open a pull request, we will create temporary environments to be able to detect and test out the new features we have done and to run all our automatic tests. When we are happy with the pull request, it will be merged, and we will actually do a push-based pipeline to production. We do not use pull-based pipelines today. We use yet another push-based pipeline that will push an artifact to the artifact store. So that was all for me. Thank you.